In this fourth video for Module 18, we consider Aeolian deposition. So previously we've looked at erosion by wind and a little bit of transportation, and now we look at depositional features. So let's jump in. Some depositional features associated with wind-blown materials include the sand plains. So sand plains are just poorly defined, just indefinite large regions just covered with some sand, not huge amounts of sand. And we'll get into sand dunes in a minute, but just a sandy surface. So a sand plain. And here's an example in the southwestern part of the Mojave Desert. A little bit about some types of dunes that form in arid environments. The Barkan Dune is the smallest, and it occurs, as I say in the caption, in varied terrain with little variation in wind direction, so a prevailing wind from one direction. And I'll show you a couple things about the Barkan Dune. I've got sort of a graphic here that represents what they look like from an oblique angle, but the gentler side is the side from which the wind blows the wind, what we call the windward side, and then there's a steeper side on the other side called the leeward side. Talked about that a little bit already. I liken the Barkan Dune. It looks like a giant croissant roll, so that's how you might remember it. But it's actually, this one is migrating in the photo from right to left. So this whole thing looks like a spaceship that sort of moves from right to left. And here's a Barkan on the ground. And you can see there's not a lot of sand around it. It's sort of an individual dune. It's not really necessarily coalescing with other dunes. It's sort of sitting by itself. And again, the prevailing wind direction here from the right, and the whole thing is moving to the left over time. And one more example of some Barkan dunes. Again, you can see that there's the wind, not a huge amount of sand, not a huge amount of vegetation, and a prevailing wind direction from just one direction. The Transverse Dune is where you have a number of coalescing dunes, if you will, where there's quite a bit more sand involved, and you have a more or less a single prevailing wind direction, but just a lot of sand. So these types of dunes just cover enormous areas. In this view from Morocco, the Sahara in Morocco near the Algerian border, just massive transverse dune covering an enormous area. The longitudinal dune has two prevailing wind directions. So here you see these elongated dunes. These dunes are sometimes called seif dunes, and that refers to like a saber. It was an Arab word for like a long sword. But we have two prevailing wind directions. We have some of the season the wind may be blowing from, let's say, the southeast, and another portion of the season it may be blowing from the southwest. So this wind direction changes a little bit, and it creates that sort of ridge line along the top of the dune. There may be some vegetation involved in these types of dunes, these longitudinal or seif dunes. But I've added the blue arrows there so you can sort of picture the prevailing wind direction changing a little bit depending on the season. The star-shaped dune can be pretty good-sized dunes. These are some of the tallest dunes in the world, and they represent where the wind shifts in direction. So we have multiple wind directions that contribute to star-shaped dunes, and some of them are really big. The ones here on the left are in Saudi Arabia. Here's a view from satellite imagery of a dune area in Algeria. So some of these star-shaped dunes are pretty big, but again, they represent where the wind is shifting. It's not coming from just one or two directions, but sort of shifting at different times of the year to create these star-shaped dunes. Just to show you how large star-shaped dunes are, I created this graphic so you can sort of visualize. So if the Statue of Liberty is 300 feet tall, we can throw the Space Needle in Seattle on there at 605 feet tall. And how about a star-shaped dune at 750 feet tall? Some of these in the Namib Desert in the southern part of Africa are massive. They're huge. Okay, parabolic dune. These are often found in sort of coastal areas, so not necessarily really super arid areas, but beach dunes, parabolic dunes. And as I say here, strong winds erode a section of vegetative sand to create the parabolic dune, and here's what they look like. We try to protect these dunes when we can with walkways. You sort of see a walkway here in the lower left-hand part of the image. So if you ever go to a coastal area and they have a walkway, try to stay on it because these types of dunes are pretty easily damaged. They're not necessarily dunes of arid regions, but they are dunes, so we sort of I kind of threw them in here with the other dunes just so you to see all the different variants. And then I think this is sort of interesting. This reversal in wind direction produces this thing called a Chinese wall. So you get this very narrow ridge right here. dune ridge. So imagine again the wind direction coming from two different sides of the dune and switching or changing periodically. We can actually put dunes onto this triangle, which represents different attributes that dunes have: more vegetation, dunes with more wind, and dunes with more sand. So we can sort of place dunes in different places. We know the transverse dunes have more sand. So let's look at a couple of these. The Barkan Dune, it's kind of in between. It has a fair amount of wind, a fair amount of sand, so it's sort of in the middle here between those two on the edge of this triangle. Not a lot of vegetation, not too much. We know the star-shaped dune is a little bit more on the more sand side, still a fair amount of wind. The transverse dunes are certainly over on the more sand side as opposed to more wind. And then we have just sort of sand plains with no dunes at all, more vegetation, less wind and less sand. And then we throw the parabolic dune sort of in the middle of the whole mix. So we can place, like I say, dunes just in different places on this graphic to sort of represent what's happening. They're the longitudinal dunes, the last ones that are shown by those elongated ridges. So a little more wind, not a lot of vegetation, not an extreme amount of sand. So those are our dune types. Let's talk a little bit about advancing dunes and efforts to stop their advance. There's really not a lot you can do when a dune is sort of moving into your area. Here's an example of a dune in China, and this Chinese farmer is just sort of perplexed about what to do because when these dunes become destabilized, they move pretty quickly, and probably the best thing to do is not to let the vegetation be damaged that covers dunes, because that's sort of helping to hold the sand in place. And I'll show you some examples of that. But once these really big dune fields start to move, there's not a huge amount you can do. Here's an example. Somebody built a fence to sort of slow down the velocity of the wind to inhibit that dune from moving, and it looks like Christmas trees have been piled up on one side of the fence to sort of aid in that process. Here's some work in one part of China where they've actually some workers very meticulously and a huge amount of labor required to try to stabilize these dunes just using vegetation, dried vegetation, to try to and again what they're trying to do is keep the sand particles from being trained or picked up by a blowing wind, lower the velocity of the wind across the sand, and you'll likely see less sand be carried. So it's important to these farmers that they don't lose their fields to an advancing dune. Here's another dune fence that's been built. These have varying levels of success, but the best ones probably are slowing down the velocity of the wind. One place that sort of fascinates me is this coastline of Namibia, the Skeleton Coast, and this is a place where the dunes continue to be pushed out into the ocean. They're sort of advancing on the ocean. You can sort of see this is over on the right-hand side here. This is actually the Atlantic Ocean. South Atlantic Ocean, and these are dune sands that have pushed out into the Atlantic Ocean. And what's sort of interesting is that if ships get too close to the shoreline, some of these sand bars will be underwater and they won't be seen by the ship's crew, and it's easy to go up on and sort of be trapped by these underwater sandbars. And there are a few cases where you can travel apparently in this desert and find ships, even a mile or more inland that were trapped in this way long ago. So here's one example of a ship that was trapped on one of these sandbars. Okay, a little bit about human impacts on dunes. I mentioned that we want to do our best not to allow dune vegetation to be removed because that destabilizes a dune. There's some sacrifice areas that are used for off-road recreational vehicles. The Little Sahara State Recreation Area here, where we go on for our in-person class for Geography 1114, we take students out there. That's sort of a sacrifice area, but the dune out there, the dunes have become destabilized. They've actually crossed over Highway 3 three different times. They've had to move Highway 3 that runs right by that dune field. So removing the vegetation has a destabilizing effect. And here's that example of what I was talking about a little bit earlier about stay on the walkway if you're in a coastal area that has dunes. Protect the dune vegetation. Don't destabilize it by walking directly on the dune if you can avoid it. I thought I'd just mention some aspects, the global distribution of some other types of aeolian materials, not necessarily found in super arid areas, but when we look at the distribution of materials that have been carried by the wind, here they are, and you can see the Sahara is sort of a dominant area. Other deserts of the world can be seen on here, but you see a few other places like Alaska that you wouldn't expect to associate with blowing materials blown by the wind. Some areas in the American Southwest look like this actually represent ancient dune fields or ancient dunes that have hardened into rock. And you can see in this example, this cross-bedded sandstone would represent different prevailing wind directions. So you see the sand was sort of laid down in layers, and then the wind direction changed, and it creates these very unusual-looking kind of wavy lines in the rock in the sandstone. Some former dunes from the Jurassic period. Again, an ancient ocean covered this area of North America at one time. These are former dunes. So you're looking at here that are sandstone. So you might ask, how was dune sand converted into Navajo sandstone? How does that happen? Well, there's some pressure from overlying layers as it's laid down. And we can say that there's a cementing effect of this mineral-laden groundwater that has some dissolved calcium carbonate in it that helps to glue those grains, those sand grains together. And there it is, Navajo sandstone of Zion National Park in Utah. So again, an ancient dune area. How about homes that are carved from windblown materials? There are actually some homes in a few countries in North Africa that have been entirely created by people that are carved out of windblown sand. And this is a troglodyte home. And here's just a fun trivia question. You may recognize this scene. This was from a movie some time ago. I'll give you a hint. The movie was from sort of the mid 1970s, 1977 to be specific. And if you recognize this place, or if you don't recognize this place, you might recognize this word. This is a welcome sign. Welcome to Tatooine. That's your hint. Of course, we're talking about Uncle Owen's home from the movie Star Wars, from the planet Tatooine. And they actually have a hotel that you can stay in here. This hotel that's shown in this picture right here. And we'll throw Uncle Owen and other Star Wars characters on here with Luke and his mom, so you can remember that location. So these homes that are made out of material, the material they're made out of is called loess. Loess is basically windblown material that's been deposited, fine-grained material. Some of it is associated with retreating glaciers, not the loess that Luke's parents' home was made out of, but loess in some other areas. This is a loess in Iowa that represents a material, a lighter material that was carried by glaciers, then picked up by wind, and this material was deposited later by wind elsewhere. And we can see some roadways that sort of dig deeply into this loess material. So all this stuff you're looking at on both sides of this picture is material that was ground up by glaciers, and then the wind picked it up, carried it, deposited it, piled it up in a big way. Here's an ancient dwelling that was carved in loess in China. So again, another example of a home that was created out of loess. And just to show you that worldwide loess deposits, there's quite a bit that was deposited in the central part of the U.S., including some in Oklahoma, a little bit covering the panhandle. So I'm just kind of zooming in here, if you will, on some large loess deposits, Missouri Valley River deposits and the Mississippi River Valley deposits of loess.